The IBM Maximo Application Suite provides clients with a comprehensive and innovative answer for physical asset management. This flexible solution provides a unified platform that delivers asset performance and maintenance management with an end-to-end asset lifecycle management across the enterprise. The application suite is built to scale a client's digital transformation journey with integrated solutions and simplified licensing, along with multi-cloud deployments. The Maximo application suite includes a suite of applications such as Maximo Manage, Monitor, Health, Predict, Visual Inspection, and more. This client demonstration provides a high-level overview of the Maximo Monitor, Manage, Health, and Predict applications, all through a story about a wastewater plant. This demo will connect these various applications, thus illustrating how they can work together to run operations within your business. A water resource authority needs to manage water and wastewater treatment assets across multiple cities and regions to maintain water quality standards. For this, rotating plant assets such as centrifugal pumps need to be constantly monitored for appropriate functioning. In the absence of an automated and scalable solution, such a task requires extensive use of manual resources, including assigning technicians to check the pumps spread across the various sites at regular intervals. In addition, there's always a risk of over or under maintenance with this strategy. Both are undesirable outcomes for this Water Resource Authority's operations. The remote operations manager and the reliability engineer both needed to understand the health of all the pumps and minimize plant downtime due to asset failures. It is crucial to accurately identify any critical asset failures to ensure a continued supply of water in a timely manner. After all, neglecting to do so could result in severe issues for the entire region. In this story, both personas will help to tackle the task in two different scenes. In scene one, the remote operational manager monitors asset in Maximo Monitor. They navigate to a summary dashboard of all the pumps and see a critical alert for a pump that decides to investigate further. After reviewing the asset's maintenance history, the manager monitors the pump's velocity using the sensor data and assigns an owner to take care of the vibration issue with the pump. In scene two, the reliability engineer views current and predicted asset performance in Maximo Health and Predict. They view the health scores of all the pumps in a single grid view. They find assets with predicted failures before their planned maintenance, and they further investigate the underperforming pump that is predicted to fail. The reliability engineer then reviews the asset detail page and the asset timeline. Now let's log into the Maximo application suite using a username and password. Once the login credentials are accepted, the Maximo application suite window opens. Several applications that make up the application suite products are displayed. In this demo, we'll focus on Maximo Monitor, Manage, Health, and Predict. Maximo Monitor and Maximo Manage are ideal starting points for many clients as they begin their journey toward a new digital operating model. Monitor provides near real-time monitoring capabilities for all enterprise assets. It's targeted to operations, and with it, clients can visualize incoming asset sensor readings on a single dashboard. They can also easily see and respond to alerts. Monitor helps to introduce artificial intelligence into operations to help recognize anomalies and eliminate false positive alerts. Clients can react to those alerts directly from the dashboard by issuing service requests or further investigate an asset's maintenance history in Manage. Maximo Monitor and Manage together reduce unplanned downtime and increase productivity. The sensor data that flows into Monitor is also the basis of analysis in other Maximo products such as Health and Predict. As a remote operational support manager for the Water Resource Authority, we need to view the status of pump assets across multiple cities worldwide. This person will need to navigate to Maximo Monitor as it provides a single place to monitor all enterprise mission-critical global assets from a single dashboard. So as the remote operational support manager, From the Maximo Suite Navigator, I'm going to click on the Monitor Application tile. I will then click on the Monitor tile on the welcome screen that opens. On the left sidebar, we'll use the right arrow to scroll to all the Maximo Monitor options. We will select Devices from the menu to view the list of device types. If we type in pump, in the search line, we can filter for pump results. We'll then click on the pump from the filtered list to view the pump summary dashboard that will appear on the right. From here, we can click on the Hide Sidebar icon to collapse it. Maximo Monitor allows users to categorize device types according to their specific use case. For example, a user can have a separate dashboard according to an asset supplier, such as OEM and non-OEM. They can also group similar types of assets to manage the performance of the entire asset set together. The Operations Manager should now navigate through the summary dashboard to see a global map of pump sites. This summary dashboard summarizes important metrics relevant to the pump, such as motor temperature, pressure valve reading, and more. This provides real-time insights on any problems with these assets. Please note that these dashboards are fully customizable. The Operations Manager notices an alert on one of the site locations in the map. Click on the alert icon displayed on the map to view a summary of the anomaly. Notice that the pump that's causing the alert is in the Bedford site. From here, we can go to the Pump Alerts tab to display a list of pumps with alerts across the entire enterprise operations. On the Pump Alerts tab, we can click on the Severity column. This will sort the alerts in descending order of criticality. Notice that there is an alert on pump device number 5. Traditional threshold-based alerts can be overwhelming. Maximo Monitor uses artificial intelligence powered by anomaly alerts to remove the false positives. As the operation manager, we decide to investigate pump device number 5 further. We will come to the Show Sidebar icon to expand it. From here, we can expand the pump category by clicking on the drop-down arrow and see the full list of pumps in this category. Clicking on pump device number 5, from the expanded list, we bring up a dashboard on the right-hand side of the page. Again, we can collapse the sidebar to view the dashboard in a full view mode. Pump Device 5 dashboard shows a picture of the pump and displays critical data about its anomaly alerts. Scrolling down to view a time series of critical pump metrics and alerts for this particular pump. The time series of critical pump metrics can be used to investigate any anomalies and take appropriate actions. For example, if the average pump pressure is declining while the average flow is increasing over time, this warrants an investigation as to whether there are leaks in the pipeline. Based on such knowledge, an operations team could investigate whether the pump needs to be serviced more frequently. Next, the Remote Operation Manager wants to look at the pump's maintenance history to see if there are any recent services done on it that could be the cause of the current problem. From here, we will go to the IBM Maximo Application Suite on the top left to get back to the Suite Navigator. We will then click on the Maximo Manage tile from the Suite Navigator to launch the application. The Maximo Manage window opens with a pre-built view of pump records. We can scroll down and click on Field Pump 5 under the non-OEM pump section. From here, we'll select the Work tab and then click on the filter icon to see if there are any available filter options. Notice there's a filter option for status. We can filter by waiting approval, approval, complete, simply by typing in the filter and hitting enter. Reviewing the pump's work history, we have this data on hand that allows us to make informed decisions on how to proceed with any maintenance. Based on the most recent work order, it looks like the water pump bearing housing and seals were replaced a few days ago. The pump ran normally for the rest of the day, but then began to vibrate again in the evening. We will return to the Suite Navigator and go back to the Monitor application for Pump Device 5. The Remote Operation Manager is now convinced that a new service request must be opened for this pump and decides to assign the maintenance supervisor as an owner of this alert. This owner will be responsible for investigating any vibrations that has returned since the seals were recently replaced. On the Pump Device 5 dashboard, we can scroll over to the Alerts section, click on the Select Owner drop-down option, and a list of maintenance team will appear for us to assign. Next, as the Remote Operation Manager, we decide to look at the Velocity X real-time sensor data in the Monitor application to follow up on the AI-triggered Velocity X alert for this pump. From the leftmost navigational sidebar, we select on the Setup. We then select Devices and type in the word pump. Clicking on the pump option from the filtered list, we then click on device number 5. Clicking on the down arrow besides metric and selecting Velocity X option from the expanded sub-menu. Notice that the graph of the Velocity X time series for this pump appears to the right of the screen. The pump's motor velocity vector is a combination of velocity in the x, y, and z axis. When an axis velocity, such as the velocity in the x-axis direction, experiences exceptional vibration, there's something obviously wrong with the pump. If a machine is having problems, it will often show signs beforehand. For example, a pump's operating motor speed or temperature may change by a small amount before the pump fails completely. These changes may go unnoticed by a human, but Maximo Monitor can use advanced AI models like anomaly detection to look at critical sensor data. It can then find these subtle changes that are often indicators of an imminent failure. This way, appropriate individuals can be alerted to take preventative action and reduce costly downtime. Going back to the IBM Maximo application suite on the top left, we will then navigate back to the Mass Suite Navigator. We are now going to play a role of the reliability engineer who must now investigate all similar pumps to the one that created multiple alerts in the previous section. This will ensure that there are no failures before the scheduled maintenance dates for the same reason. Maximo Health and Predict can provide a view of the current state of all enterprise assets, including pumps, as well as AI-powered insights into the projected future condition of those assets. From here, we will click on the Health Application tile from the Suite Navigator. The Maximo Health Assets page opens. The Maximo Health Assets page provides a universal view of all of the Water Resource Authority's managed assets. This is valuable to the reliability team as it allows them to see both IT data and operational technology data together in a single view. Many failures cannot be prevented with the traditional time-based preventative maintenance strategies or solely based on sensor data. Individually, this data not only provides part of the picture, insights on the past maintenance issues and service requests, the age of the asset, and the historical investment enhances the sensed conditions of an asset with real insight. This is the power that Maximo Health and Manage provide. With hundreds of assets deployed in any given complex operation, Maximo Health provides flexibility to generate and customize different views of asset data to make it easier to identify critical assets. Users have the option to add and more columns, filter, search, and sort accordingly to their roles and responsibilities. In the next steps, we will utilize a pre-configured saved view that helps make repeated pump performance monitor easy and quick. This view includes filters on selected pumps, a pump status column, and sorts them by OEM and non-OEM suppliers. From here, we will click the selection box drop-down from the top section of the view of all the pre-saved views. We will select the pumps with status, which is a shared view from the drop-down menu option that appear. In this saved pump view, the engineer can see two columns with calculated data, health and days to failure. Health scores provide a powerful and simplistic approach to combine and distill an asset's condition assessment readings and historic maintenance history in a simplified, color-graded numeric scale. Similarly, days to fail can help proactively identify assets that are going to fail in the next few days or weeks, allowing engineers to perform necessary corrective maintenance before any downtime occurs. As the reliability engineer, we can look at the health and days to failure scores for various pumps to gauge the risks of multiple pump failures. A lower number of health scores means deteriorated asset health. It should be noted that risk tolerance can vary among industries, asset types, and enterprises. Monitor allows companies to define the health scoring ranges specific to their business operation tolerance levels with their own color scheme. Clicking the map icon at the top right of the screen, we will view the health score of each of these pumps on a map view. Seeing how the assets are spatially distributed, along with their health score grade, assists the reliability engineer to identify and investigate assets at risk. This particular true in the utilities industry, where assets are typically spread over a large geographical area. The reliability engineer continues their investigation to determine which water pumps are expected to fail soon, yet don't have a maintenance plan to address the failure. These are the assets that are more likely to result in unplanned downtime. The easiest way for a reliability engineer to do this is by using the work queue feature built into the Maximo Health and Predict. Clicking the work queue menu option from the left sidebar menu, we will see available queues. Work queues are pre-configured views designed to help users find what they're looking for and to manage their day-to-day activities. These are particularly valuable to a reliability engineer who needs to address a specific problem, like a water treatment plant trying to avoid unplanned downtime. There are several work clues included in the Maximo Health and Predict. These include high probability of failure, low health, and failing before preventative maintenance. There are also work queues that show assets with missing data. Work queues describe missing data are extremely useful to the reliability engineer as they can help identify gaps in data necessary to create health scores or predictive failure modes. Select the Failing Before PM work queue to see all the assets that are predicted to fail before planned maintenance work is scheduled for them. It's critical for the reliability engineer to address these assets to avoid downtime for the water treatment plant. Notice this work queue shows that there are no assets predicted to fail before their scheduled preventative maintenance. From here, we will click the Assets menu option from the left sidebar menu to go back to the pump's asset view. From here, we'll click on Pump Device 5 from the list. We're now looking at a detailed overview of Pump 5's health score. Please notice that Pump 5's asset health is detailed on this page. It's an incredibly useful tool for investigating a pump's current and predictive future conditions. The reliability engineer can find all the asset information presented on a single page and in an easy-to-read tables, charts, and graphs. The KPIs at the top of the asset health detail page provide a snapshot of the current state of this pump. The health score of the pump is listed, and its previous health score was calculated. The tile cards also show the increase and decrease in asset health since the last calculation. Clicking on the KPI tiles provides a brief description about the corresponding metric. For example, if I click on health, this is the overall condition of the asset on a user-defined scale. This helps to gauge the general maintenance needs of an asset. As for criticality, if we click on criticality, the importance of an asset to its business. This helps to prioritize maintenance and repair activities. Looking at risk, it's the probability of a high impact failure. This helps to identify potential problems before they occur. End of life is the probability of an imminent end of life failure. This helps to schedule replacement of the asset in a timely manner. We also have the effective age, that is the actual age relative to the asset's current health score, and this helps to determine the remaining useful life of the asset. The next PM is the days until the next scheduled generation of a preventative maintenance work order. The card is empty if the generation date is the current date or no work order generations are scheduled. This helps to ensure that the PM work order are generated in a timely manner. Maintenance to replacement ratio. This is calculated by dividing the current total cost of all maintenance for the asset, including parts and labors, by the replacement costs. If the percentage is 100% or greater, the current total cost of the asset is greater than the cost to replace the asset. Finally, we have next to failure. This is the time until the asset is predicted to fail, according to a predictive model. This helps to prioritize action and schedule asset maintenance. Below the KPI section, the reliability engineer can view more information about this pump, which comes directly from the Water Resource Authority's Enterprise Asset Maintenance System. In this case, we're using Maximo Manage. Looking at the health details, this section shows a breakdown of the health score and factors that provide insight into what is causing the pump's poor health. For this asset and the assets in the same group, the reliability engineer can see that the health score is a weighted average of open work orders, remaining useful life, and meter health. Once the reliability engineer decides on what action to take, it can be immediately turned into action from the top of the page. They can create a service request, create a work order, recalculate a health score, or edit the source assets record. The reliability engineer can finally create and present a detailed report of the findings about current and predicted future of device 5. Maximo Predict includes templates to help enterprise data scientists to get started with building models to predict days to failure, calculate probability of failure, detect anomalies, and generate an asset's life curve based on the asset's deployment and retirement dates. These templates include many algorithms, and the data scientists can select the one that best fits their data and needs to drive for optimal outcome. In addition, the Maximo application suite includes Watson Studio and Watson Machine Learning, which can be used for building, training, and maintaining predictive models if a more custom solution is needed. Scrolling down, we're going to go take a look at the Predictions tab. The prediction section opens, showing the selected pump's predictive KPIs and failure probability. Again, if we were to click on the headers of each tile, brief information about its contents can be found. The AI model predicts that this pump will fail within a certain number of days, plus or minus a specified period. In this case, it's 3,192 days. If the data history of this asset is rich enough, a data scientist can also build predictive models for specific failure modes. It helps to know the probability of failure along with the most probable failure reason, which is your failure mode. For example, knowing information such as there's a 50% chance this pump will fail in the next 3 days due to a motor failure is very useful. In this case, the model would look for a sequence of events that led to this failure mode and provide the pump's probability of failure due to its motor burnout. In this way, it helps to plan for preventative maintenance actions. The time frame of the training data, this tile can help to decide if and when an AI should be retrained. On the failure probability, notice that probability of the failure occurring in the selected prediction time window. You can see that this pump has a 50% chance of failing in the next 3 days. Scrolling down to the failure probability trend, this card shows that the failure probability history of each mode, indicating how the probability of failure has changed over time. Looking at the factors that contribute to failures, it shows which factors from the training data had the biggest impact on failures. This gives an idea of what might cause future failures. Looking at the anomaly detection and the anomaly detection history, these cards show the anomaly scores for this pump as well as when it crossed the threshold. The threshold is your red dotted line. We'll now go to the asset timeline section. The Asset Timeline tab provides several pieces of key information about this asset within a single graph. Looking at this timeline, the selected pump has a predicted failure date that will occur way after its next planned preventative maintenance schedule date. This chart can also show valuable pieces of information like past work orders and inspection dates on a specified range, which provides valuable insight into the asset's history and may support what kind of action needs to be taken. This end-to-end demonstration has shown how a remote operations support manager can use AI anomaly detection to monitor all of their enterprise pumps in near real time. This eliminates false positive alerts. This persona was able to investigate an asset in trouble and submit a service request by using Maximo Monitor and Maximo Manage. This demo has also shown how enterprises can detect the current and predicted future conditions of thousands of assets at scale using Maximo Manage and Predict, thus ensuring that operational teams aren't over or under maintaining assets. As users address the assets in a work queue, they can provide their organization tremendous value by reducing downtime, saving on maintenance and operational costs, and increasing revenue. This is the end of the demonstration. Thank you for your time.